Hey there, science fans! Today, we're diving into the fascinating world of friction. What is friction? It's a force that opposes motion. Imagine trying to slide a heavy box across a rough floor. That resistance you feel? That's friction at work. Frictional force always acts in the opposite direction of the applied force. It's like an invisible hand trying to keep things from moving or slowing them down. Friction is everywhere, from our everyday lives to the workings of machines. But what causes friction? Let's find out. You might think that smooth surfaces are perfectly smooth to the touch, but if you could zoom in with a super-powered microscope, you'd be surprised at what you'd find. You'd see tiny bumps and ridges that are invisible to the naked eye. These microscopic irregularities interlock when two surfaces rub together, creating friction, which is a force that resists motion. The rougher the surfaces, the more friction is created due to increased interlocking. Think about sandpaper. Its rough texture creates a lot of friction, making it effective for smoothing out rough surfaces. That's why it's great for smoothing out wood, but not so much for sliding furniture across the floor, where it can be quite a hassle. Now, let's see how friction can be both helpful in our daily activities and sometimes a bit of a nuisance in certain situations. Friction might seem like a pain when you're trying to move something heavy. It can feel like an invisible force working against you, making every push and pull a challenge. But it's actually essential for our everyday lives. Imagine a world without friction. It would be chaotic and unmanageable. Without friction, we wouldn't be able to walk, drive, or even hold a pencil. Our daily activities would be impossible to perform. Friction allows us to grip objects securely, whether it's turning a doorknob or holding a coffee cup without it slipping from our hands. It helps our cars stay on the road and our shoes from slipping on the floor, providing the necessary traction for safety. Friction is also crucial for braking and bringing moving objects to a stop. Without it, controlling speed and stopping would be nearly impossible. However, too much friction can be a problem. It can make tasks more difficult and cause unnecessary strain. It can cause wear and tear on machinery, create heat, and make it harder to move things efficiently. This can lead to increased maintenance and energy costs. That's why we use lubricants like oil to reduce friction between moving parts. Lubricants help machines run smoothly and extend their lifespan. Now, let's take a closer look at the different types of friction. Each type has unique characteristics and plays a vital role in our world. Section 4. Static friction, holding things steady. Imagine trying to push a heavy sofa across the room. At first, it might not budge. That's static friction holding it in place. Static friction is the force that prevents an object from moving when at rest. The heavier the object, the stronger the static friction. It takes more force to overcome static friction and get that sofa moving than it does to keep it sliding once it's in motion. But once that sofa starts moving, we encounter a different type of friction. Section 5. Sliding friction. Resistance in motion. Once you overcome static friction and get that sofa moving, you'll still feel resistance. That's sliding friction, also known as kinetic friction, at work. Sliding friction is the force that opposes the motion of two surfaces sliding over each other. Think about pushing a box across a table. Sliding friction makes it harder to keep the box moving at a constant speed. The smoother the surfaces, the less sliding friction there will be. So, how do static and sliding friction compare? Section 6. Comparing frictions: static, sliding, and rolling. In this section, we will explore the different types of friction and how they affect motion. Remember how it took more force to get that sofa moving? You had to push really hard to overcome the initial resistance. But once it started moving, it was easier to keep it sliding, right? That's because static friction is usually stronger than sliding friction. Static friction acts when an object is at rest, and it takes more force to break this hold. It takes more force to break the hold of static friction. Once the object is in motion, sliding friction takes over, which is generally weaker. But wait, there's another type of friction: rolling friction. This type of friction occurs when an object rolls over a surface. Rolling friction is the force that resists the motion of a rolling object, like a wheel or a ball. It's much less than static or sliding friction. Rolling friction is much weaker than both static and sliding friction. This is why wheels are so effective in reducing effort. That's why it's easier to move a heavy object on wheels. The wheels reduce the friction, making it easier to push or pull than to slide it across the floor. Sliding a heavy object requires more effort due to higher friction. Rolling friction makes transportation much more efficient. Wheels and rollers are used in many applications to make moving objects easier. And that, my friends, is the fascinating world of friction in a nutshell. Understanding these concepts can help us in everyday tasks and in designing better tools and machines.